welcome to another nostalgic math chat. Oh, sleepy voice. Okay, I hope it'll wake up in the midst of recording. Right, we are busy with the IEB May 2023 paper 2. This is question 9. Let's look at it. In the diagram, triangle ABC is drawn. Please, in as much as it kind of looks like it could almost be right angled, do not assume that unless you're told. Anyway, that's just what my brain immediately wanted to assume, is that it's a right angle triangle. But we have been given no information to indicate that so far. Right, E and F are points on AC and AB respectively. Okay, you can see that. Such that AE over EC is equal to 3 over 2. So what that means is, if this is 3 units long, then this will be 2 units long. If this is 6 units long, then this will be 4 units long. So they exist in a ratio of 3 to 2. So, okay, cool. And then we're also told that AF over FB is 2 over 5. So similar reasoning. If this is 2 units long, then this would be 5 units long. If this was 4 units long, then this would be 10 units long. If this was 6 units long, then this would be 15 units long, right? So that's the relationship between them, 2 to 5. Okay, righty doos. BC produced meets FE produced in D. So if we take BC and we extend it, and we take FE and we extend it as well, then they meet over here at D. So whenever we see lines being produced, we're just talking about, just think of BD as one long straight line, FD is also one long straight line. G is a point on FB so that FD and GC are parallel. Nice. Okay, and of course, the moment I see anything like this, it's giving similar triangles, and this ratio stuff is also just kind of hinting towards that. So that's kind of where my brain is currently. Let's see what the question requires of us. Calculate, giving reasons, the ratio between BC and CD. Okay, and what immediately stands out for me about those two line segments is that we have this shape that I was talking about, right? We have this triangle BFD and the two parallel lines. So triangle BGC and triangle BFD are similar. So that might come in handy. And then we also know, okay, we've been told the ratio between AE and EC is 3 to 2. So that has to do with the similarity of these two triangles. Okay, and then we're also told AF, maybe a different color will do. We're told that AF and FB, we're told the ratio between them is 2 to 5. that could almost be helpful. That could almost be helpful because BF is part of triangle BFD, and that's ultimately the triangle we want to work in, right? So, yeah, okay. I think I have an action plan, right? So, we know the ratio between AE and EC, which means we know the ratio between AF and FG, right? Then we know the ratio between AF and FB. So that could help us, using all of that information together, could help us figure out what is the ratio of this piece relative to that piece, which would help us figure out the ratio between that piece and that piece. Okay, so what I'm going to clean this up again for the millionth time, and let's try and yeah, okay, cool. So first I need to show that the triangles AEF and ACG are similar, so that I can apply this ratio over here as well. So let's do that. So we have in a different color, in triangle AEF and triangle ACG. Okay, we have that angle A is common to both triangles. Okay, we have that angle AEF is equal to angle ACG. Okay, so this guy is equal to that guy, and that's because of corresponding angles on the parallel lines EF and CG. Okay, and then angle AFE is equal to angle AGC. Again, we can use corresponding angles, or we can talk about the fact that they are both the remaining angle in the respective triangles, so they must be equal. If the other two are equal, then the third angle must be equal. I don't know if that's still a valid reason, like you can just say third angle, but yeah, anyway. So we have now proven that triangle AEF, and remember order matters, so AEF, okay, is similar to triangle ACG, and again order matters, ACG, right? So we need to see from the order of the letters that which angles are equal. So angle A is equal to angle A, angle E is equal to angle C, and so on and so on, right? Because when you set up the statements about which sides are proportional to each other, that order will be significant, right? So this is by the reason of angle, angle, angle. Okay, now the moomish that I have performed is I have written on my picture, and now I don't know if I'm going to be able to move it. I don't think I will, but I will try. A girl has got to try. it's disappearing. Yeah, this is not doing what I needed to do. Okay, next plan is to just duplicate it and then move it down. And then over here, I will delete the picture. Oh, heartbreak, heartbreak. Okay, yeah, this was unwise, hey? Okay, let's just keep the picture fine. We'll just ignore the picture. Right, let's move it all the way. This is always so painful. Like, it really just pains my heart how difficult this is. This should not be so hard. Why is it so hard to do? Okay, right, so we'll just bank our workings over here. Okay, right. And then what I'm going to hold on to over here, I'll just probably rewrite that because trying to move it is going to be way too hard. Okay, so we are going to hold on to the fact that triangle AEF is similar to triangle ACG. Okay, and we can get rid of that. Okay, right. So now we can use that fact to say, okay, therefore, AE, therefore, AE over AC is equal to, and we're interested in this side, so AF over AG. Okay, and if we know that the ratio between these two is, if this is 3k, then this will be 2k. So 3 times 1, then this will be 2 times 1. If this is 3 times 5, then this will be 2 times 5, right? So we know the relationship between them is 3k to 2k. Then the relationship between AE and AC, so the whole side, will be 3 to 5, right? Because the whole length of the side will be, if AE is 3k, then the whole of AC will be 3k plus 2k, which is 5k. So the relationship between them is 3 to 5. So this fraction here is 3 over 5, right? So that's the relationship between AF and AG, right? So all of this gevaffel for something that we already just kind of knew from the jump, but it's very important that nothing can be assumed. Okay, you must explain how you've arrived at every conclusion. So yeah, so we now have that if this is 3m, hypothetically, then this whole side is 5m according to the statement, right? And therefore this little piece over here would be 2m. Okay, so the relationship between AF and FG specifically is also then 3 over 2. Right, now what I'm interested in is, okay, moving into this triangle, right, and figuring out the ratio between this side and this side. Okay, so far what we know is that the ratio between AF and FB is 2 to 5, right? So again, yeah, it'll be 2 to 5 or 4 to 10 or 6 to 15 and so on and so on, as explained earlier. So, what I now want to say is, if I know, for example, okay, so we know that the ratio between AF and FG is 3 to 2. Okay, so that means if this side is 3m, then this bit over here will be 2m, right? So I want to rewrite this ratio so that the AF bit is also a 2, because then that will allow me to figure out what is the relationship of this relative to this whole bit. Because I know that if this bit is a 2, then this whole bit is a 5. But if I know that how much this is, if I know that this little bit will be 1.5, then I know that the rest of it will be 3.5, what makes up the rest of the 5. I can't do that comparison currently because this ratio, right, the AF is a 3. But if I can change it so that it's a 2, then I'm able to work across the two ratios easily. So I want to rewrite, what am I undoing? I don't even know anymore. Okay, I want to rewrite this ratio so that there's a 2 at the top. So probably easiest, how would I do this? Yeah, what we can do is we can say, well, to get from 3 to 2, I need to times this number, this 3, by 2/3, right? And that will give me the 2 that I want at the top. But then I need to do the same at the bottom, right? So that I haven't changed the fraction. So if I do the same thing at the top and the bottom, well, if I times by the same number at the top and the bottom, it's just the same as timesing by 1, right? 2/3 divided by 2/3 is just 1. So we haven't actually changed the number. So 2 times 2/3 is 4/3. Okay, so we've taken this ratio. We're still saying the same thing here, right? We're just expressing it in different terms, but it's still expressing the same relationship. So now what we know is that, okay, we now know that if this piece over here, and I'm going to stop talking about it in terms of k's because I hope we get the point, but what we've expressed now is that if this length was 2, then this little chunk over here would be 4/3 or 1/3, right? But we also know that when this length is 2, then this whole length over here is 5. So then that means this little piece over here, this BG specifically, would be 5 minus 4/3. Okay, so let's write that down. Okay, so right, we know that the ratio between AF and FG is 2/4/3, and we also know that the ratio between AF and FB is equal to 2/5, right? So what that means is, therefore, the ratio between let's say FG and FB, okay, is going to be the same as this over this. It's going to be the same as 4/3 divided by 5, And if we simplify that, where's my calcs? 4 over 3 divided by 5, right? That's the same as 4 over 15. No. The pain of my existence. Okay, so that's the same as 4 over 15. So the ratio between this bit and that bit over there is 4 to 15. Okay, so I've kind of abandoned my original train of thought because it's not really necessary. But yes, let us hold on to this finding over here. So now, in order for us to apply this ratio to this side, we need to show that this triangle and this triangle are similar. Okay, so let me first clean up a bit and then we can head into that. Okay, so again, I've written on the drawing, which is just tragic. So it will all just have to come along. Nice. Okay. Right, so back up we go. Okay, so I just need to rewrite this little finding of ours. So FG, the ratio between FG and FB is going to be 4 over 15. I'm now wondering if a simpler way to say this, so I mean we found from this statement here, right, we determined that AE over AC is the same as AF over AG, right? And we were given that ratio as 3 over 2. Okay. And then we were able to determine that, okay, the ratio between AF and FG is sorry, I messed that up, sorry. This is 3 over 5. This is 3 over 5. That's what we determined. AF over FG is the one that we were given. It's the 3 over 2. Right? And then we also know that AF over FB is 2 over 5. So if we were to just say AF, okay, that ratio divided by this ratio, which is the same as AF over FG times the inverse. Okay, so then those guys cancel out, right? So then we're just left with FB over FG. And what is that? FB over FG. Okay, so that means we could have done our division the other way around, but anyway. So that would tell us we also know that, okay, we'd have to just figure out what is 3 over 2, which is this guy, divided by 2 over 5, which is the same as 3 over 2 times 5 over 2, which is the same as 15 over 4. Right, so what that is telling us is the ratio between FB and FG is 15 over 4, which is pretty much what we found, right? We found FG, the inverse, FG over FB is equal to 4 over 15, right? I actually think that's a way more straightforward way to arrive at the same conclusion. Okay, but anyway, here we are. I am going to also move this. Well, I hope that this one I can move without moving the picture. Yay! Okay, so this is an alternative and I think a lot cleaner of a way to find a way to get this ratio and this ratio to interact and tell us about the ratios of the sides in these two triangles. Alright, let's also then move this guy. Okay. Oh, yes. Right. So now that we know that the ratio between FG and FB is 4 to 15, if we can show that these two exist in the same ratio, then we are hitting our home run. So we need to show that triangle BGC and triangle BFD are similar. So similar to before, in triangle BGC and, okay, let me try and minimize my heartache. Okay, like let's actually not write on the picture. So in triangle BGC and triangle BFD, right, same old, B is common. Angle BGC is equal to angle BFD, and that's because corresponding angles on parallel lines GC and FD, okay, and then lastly from BCG is equal to angle BDF. For the same reason, corresponding angles GC is parallel to FD, right, and therefore triangle BGC is similar to triangle BFD because angle, right, okay. And so then we know that BG over FB, sorry, just had a temporary brain freeze. Maybe let's be consistent here. BG over BF is going to be the same as BC over BD, right? And we know that because FG to FB is 4 over 15, we know that BG over BF must be equal to 11 over 15. Okay, and that's since FG over BF is equal to 4 over 15. Alright, then this must be 11 over 15. Right, and so therefore BC over BD is also going to be 11 over 15. Right, we're almost there. So we now know that BC, if that's 11, then this whole thing is 15, and we've been asked for the ratio of BC to CD. Right, so if this is 11, then this remaining bit is 4, and so the ratio between BC and CD would be 11 to 4. So therefore the ratio between BC and CD would be 11 to 4. Let's see if the memo agrees. What question is this? Question 9. Yes. 11 over 4. 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 Right, perfecto. Sorry, that was me trying to figure out how the memo went about it. Anyway, see you in another vid. Oh.